The next thing we want to look at in part 2 of conservation of momentum is collisions that are known as inelastic collisions. In inelastic collisions, we're going to be looking at collisions where objects stick together. Two objects collide, stick together, and move as a common unit with a common velocity. So in this case, we still have the initial momentum of object 1 plus the initial momentum of object 2. They're moving separately. Then they're going to stick together. So we're going to do the momentum of object 1 plus 2 since they're all one object. So we'll add their masses together. They'll have the same velocity. So that's why this equation looks slightly different than last time, because these two objects are going to stick together and form one mass. So let's look at some examples of these. I would recommend trying each of these examples on your own before watching my explanation. 500 kilogram railway car traveling at 20 meters per second to the right strikes an 800 kilogram railway car traveling at 10 meters per second. If they stick together, how fast are they moving? And this we'll say that this railway car is traveling to the right also. It didn't specify. So we have car 1, we have car 2. So the mass is 500. The initial velocity is 20. The mass here is 800. The initial velocity is 10. We're looking for the final velocity of both. But since they're stuck together, they'll have the same final velocity. So m1, the initial 1, plus m2, the initial 2, equals m1 plus m2 times v final. So 500 times 20 plus 800 times 10 equals 500 plus 800 times v final. So we get 10,000 plus 8,000 equals 1,300 v final. So 18,000 equals 1,300 v final. It's 13.85 meters per second. That should be logical. If we have a heavier object, a faster moving object hitting a heavier, slower moving object, they're going to stick together and move it somewhere in between the two speeds. The fast one's going to slow down, the slow one's going to speed up, and it's going to be closer to the heavier object's mass than right halfway in between. 2 kilogram blob of putty moving at 4 meters per second slams into a 6 kilogram blob of putty that's at rest. What is the velocity of the two stuck together blobs immediately after colliding? So we have number 1, we have number 2. Here we have a mass of 2 kilograms. Here we have a mass of 6 kilograms. Here we have an initial velocity of 4. Here we have an initial velocity of 0. We're trying to find the final velocity of both. So this is this inelastic case. m1, the initial 1, plus m2, the initial 2, equals m1 plus m2 times v final. So 2 times 4 plus 6 times 0 equals 2 plus 6 v final. So we're going to get 8 plus 0 equals 8 v final. So 8 equals 8 v final. Final velocity here will be 1 meter per second. Another one, a 300 kilogram truck moving rightward at a speed of 5 kilometers an hour collides head-on with a 100 kilogram car moving at 10 kilometers per hour. Two vehicles stick together and move at the same velocity after the collision. So we have our truck and we have our car. Truck, mass of 3,000 kilograms. Car, mass of 1,000 kilograms. Initial velocity of the truck is 5 kilometers per hour. Initial velocity of the car is 10 kilometers per hour. And we're looking for the final velocity of both. So M1, the initial 1, plus M2, the initial 2, equals M1 plus M2 times V final. 3,000 times 5 plus 1,000 times 10 equals 3,000 plus 1,000 V final. So we get 15,000 plus 10,000 equals 4,000 V final. So 25,000 equals 4,000 V final. We get a final velocity of 6.25. Not meters per second here because we started in kilometers per hour. So it will now be 6.25 kilometers per hour. Okay, so that takes us through inelastic collisions. The next video we'll look at explosions and then do some mixed examples.